Hi, and welcome to this presentation about linking events to achieve traceability and data aggregation in CI/CD systems. My name is Emil Bäckmark. I work as a CI/CD architect in Ericsson. Let me start off with a statement from one of the most read news sites on cybersecurity. The average software application depends on more than 500 open source libraries and components. And the same report also states that 75% of the source code in average software application is open source libraries and components. So how do you know when you should update any of those? It could be quite crucial to update your dependencies as soon as possible to avoid that your software contains critical security vulnerabilities, for example. In this presentation, I will follow this agenda. I will start off with some basics about what events are in this context. I will then discuss what event links are. And then I will come into the main topics of traceability and data aggregation. I will continue talking about some additional benefits with linked events. I will mention briefly about storing these events, and I will finish up with discussing how linked events are used in practice. So, what are events then? According to this definition made by CloudEvents, which is a standardized generic event protocol that has gained a lot of interest lately, an event is a data record expressing an occurrence and its context. Events are routed from an event producer, which is the source, to interested event consumers. The routing can be performed based on information contained in the event, but an event will not identify a specific routing destination. Events will contain two types of information, the event data representing the occurrence itself, and context metadata providing contextual information about the occurrence. A single occurrence may result in more than one event, according to CloudEvents. In a CI/CD context, events can be used for triggering software pipelines and propagating information in a CI/CD system. Examples of events relevant to a CI/CD context are the ones describing, for example, that some source code has been pushed for review or has been merged, that an artifact has been built or published, that some tests have been performed, and maybe that a certain level of confidence is reached through those tests. CI/CD events could also describe that individual pipeline steps have been queued or that they have been started or finished. To exemplify what an event could look like, I made up an example here based on the CloudEvents JSON schema. An event should, for example, contain a type, a unique ID, the source of the event, and a timestamp along with a lot more properties. So what are these event links then that we talk about? When events are sent from a CI/CD system, they normally have natural relations to each other. For example, a build often follows after a source change that is merged, and a test activity often follows after a build, etc. And as I mentioned previously, events should have unique IDs. And what we mean with event links is essentially then a reference to the ID of a previously sent event. So in this picture, time goes first from left to right. So event A is sent first and event B comes after it. We see that event A has a unique ID and the name of it is event A in this example. Event B has more or less the same properties, but it also contains a links object. The links object contains a target to which it's referencing, and the target is made up of just the ID itself of the previous event. So an event link is essentially a reference to a previous event ID's field. We could also add a third event to this picture. And to trace back from event C to event A, you will need to follow links recursively backwards. First, from event C, you will go to event B, the ID there, and from event B, that event, you will go and find up the event A. So The current event, event C in this case, does not contain a link to all previous events explicitly. This might raise concerns about storing and querying old events, and I'll come back to that later in the presentation. It's also so that CloudEvents states that publishers should keep events compact by avoiding to embed large data items into event payloads, and rather use the event payload to link to such data items. And it follows with, from an access control perspective, this approach also allows for a broader distribution of events, because accessing event-related details through the resolving links allows for differentiated access control and selective disclosure, rather than having sensitive details embedded in the event directly. All of that is from the CloudEvents specification. So by linking events to each other in the way we propose here, the event payload can be kept down to a minimum. Now, linking events with anonymous links, as I showed on the previous slide, enables some benefits, but the real gain comes if we also add types to the links, thus making those links semantic. In this example here, we again see three different events, event A, B, and C. Event C in this picture has multiple targets, as you can see. It references both event B.id through some type X, and it references event A.id through some other type. And these types could then explain what kind of relationship event C has with those two previous events. So for example, event C could be an event describing that a component has been built. Then event A could describe the source change in a library involved in the build. And event B could describe another source change, making this component C here, or the component referenced by event C, to become an integration of two subcomponents. Similarly, multiple events could also link to the same previous event, where each link could have different types as well. And in this example, event B and C could represent two different deployments, for example, of the same component, where the component is represented by an artifact or image built and notified through event A. If we now extend this event links to a more complex picture, we can see that events and links naturally form a directed acyclic graph, where events are the nodes and the links are the edges in the graph. An event can only reference to previous events, and thus there will be no circular references. I would also argue that executions of CI/CD pipelines are directed acyclic graphs in their nature, where all pipeline steps are activities with natural links to previous activities. So events emitted from such pipelines should also be possible to represent as directed acyclic graphs. Now, why should you then link events in this way? Let's go into the main topics, the topics of traceability and data aggregation. And we start with traceability. So with the graph of linked events from your CI/CD system, you can trace events end to end to find what has happened in the complex production flow, from the earliest source code commit, which we exemplify to the left in the picture here, of a low-level library, all the way to a customer deployment and beyond, if you like. You can also trace backwards or upstream, as we call it, to find out, for example, what source changes were involved in a certain artifact version, denoted by this green bubble here, even if those source changes were made by different organizations and in different SCM systems even. We also trace forwards or downstream to find out, for example, where a certain application has been deployed, even if those deployments are made in different target environments and in different customer networks even. So traceability is crucial when, for example, a bug or a security vulnerability is found in a deployment. When traced back to a bug in a library, way to the left here, we also need to trace it forward to see what deployments that library were part of. This is needed regardless of who developed the products and what tools were used for it. And if we zoom into an individual software pipeline development project, we can also see benefits with traceable links in here. For example, when building and testing for multiple targets in parallel. In order to visualize or measure on the events coming from your pipeline, you would benefit from having semantic links. In this example, we see two different targets, one for Linux and one for Windows, and we make two parallel builds, and we also test them in parallel in this pipeline example. After the tests are successfully performed, there will be a common release for the whole component. And if we would send out events from all of these 6 different steps, there will be 6 serial events coming in time. Then through the links that we introduce, we can then build up this graph of activities from the pipeline. So the build for Windows and Linux, they are done in parallel. Both of them refer to the source code event that was previously sent. Then we have 2 different parallel test activities. They are not directly related to each other. They are in parallel. One of them references the Linux build and one other references the Windows build. And then we have the release activity in the end, which then references both test activities from Linux and Windows in this scenario. We can also use traceable links for dealing with visualization or calculating measurements or KPIs for pipelines with rerun functionalities. In this example, we see a pipeline which has a failing unit test in it. So the third event coming here signals that the unit test failed. Then it could be so that our pipeline engine has possibilities to rerun things when they fail, for different reasons, of course. So then there will be a new unit test event sent out after that activity is done. And if that succeeds, then it will try to continue. But how should we then visualize this? Well, since the second unit test activity here has a reference to the original build activity directly, we could easily visualize it with a successful unit test following that build. The same for a failing component test. And if that again succeeds after a rerun, we can visualize that now we have a successful run of this component test. And then we could release it afterwards. So these are 2 examples of how traceable links could be used in individual software pipelines. Now, aggregating the data from these events that are linked with semantic links enables complex computations such as key performance indicators, KPIs, pipeline metrics, and test reports of any kind. Analytics calculations can span multiple provider and end-user organizations through these links. In order to perform complex triggering based on data from multiple events, the events could strongly benefit from being connected through semantic links. We could trigger on certain upstream builds or releases based on linked information, such as trigger on each release of a certain upstream library. So this is triggering on a release of an upstream library here, in which this other library is also updated. So there could be another library here, which is used in this build. So when that happens, when there's a build here, which then has a reference to this library back here, we would then trigger the next activity here. An example could be that we should trigger on any build from a certain upstream library, but we should wait for a certain confidence level to be reached for that build before we actually run it in our production environment. Another example could be that we want to trigger on any release of a certain upstream library again, but that has also been built and tested into this other application and maybe in another organization completely. So these are 3 different examples on how aggregations of events could help us triggering complex pipeline activities. Now, Are there more benefits with using links of events in your CI system? Yes, so links could answer, for example, why was this artifact built, representing causality in your pipeline. It could answer, what does this artifact contain, or what baseline was used when building this piece of software? It could also answer what environment was used when testing this application, given that you send, of course, events for an environment created and so on. Events could enable the development of generic tools for the CI/CD ecosystem that send and consume these events. Links can be leveraged by machine learning algorithms, as events with semantic links has explicitly typed relations, and as the chain of events can be represented by a directed acyclic graph. Links can also be used to build product structures on the fly, as the linked events could describe an arbitrary depth of hierarchical product dependencies. So by now you've probably started to think about how an event consumer can look up these events that are linked from an event that is consumed. Doesn't that require a persistent store of all historical events? Well, to some extent it does, and it could be a challenge. There are several ways to deal with that, though. You could have a central event store where all events are globally stored. It could be a distributed database with clever lookup and query distribution algorithms. Alternatively, you could have a domain event store or a local event store in your network or your cloud, where you store all the events that your internally deployed consumers could be interested in listening to and querying for. You could also have a local store in the consumer itself. As all events are typed and the links are semantic between these events, it should be possible to store just the events that you will be interested in keeping. And with a combination of these stores, we should be able to deal with connected events sent from a CI/CD system end-to-end, spanning over multiple source code communities, as well as multiple end-user environments. So now it's time for reality check them. Are these linked events used in practice anywhere? Yes, they are. So my company where I work, Ericsson, is a telecom networks provider focusing on mobile networks and services. We are about 100,000 employees worldwide, and our R&D organization holds about 25,000 employees. Most of those R&D people are involved in some kind of software development or production. Several years ago, we developed and started to use internally an event protocol that we call IFL. It was open sourced to the public a few years back, and is now maintained on GitHub by a community with representation from diverse businesses such as security business or surveillance and the truck building business. In Ericsson, we have developed plugins and adapters for managing these events to several of the tools that we use in our CI/CD systems. And we send millions of these events daily in our software production pipelines. With these events, we track hundreds of dependencies internally through the linked IFL events. We aggregate data from the linked events to calculate lead times and other key performance indicators. We trigger delivery pipelines and also software baseline uplifts on these linked events. So what have we learned now? Well, linking events together enables traceability and data aggregation over arbitrary many dependencies between libraries, components, and applications. Now, how could you use links then? What could you do now? If you want to be part of developing a common event protocol for CI/CD, then I would like you to come to the special interest groups for events in CDF, in the Continuous Delivery Foundation. In this group, we collaborate with major CI/CD players like Tekton, Jenkins, Tekton, Ortelius, Spinnaker, and more. If you want to use an existing event protocol for CI/CD that uses the concept of linked events, then I would urge you to come and join us in the IFL community. For that, you can get involved already now. In just about 10-15 minutes, maybe, there will be a birds of a feather session with the events special interest group right after this presentation. And that leaves me to the Q&A session. Thank you. Hello, everyone. Nice to see so many of you. So have you prepared any questions for me now? I've seen one question and I tried to reply to it. I hope that I did. If not, then please reach out with a follow-up question. Seems my message was crystal clear. It's nice to hear. So if you're interested, I can provide some links that are actually in the presentation, but if you didn't see them passing by, I can paste them here in the chat for you. So here you have the, sorry, let's see. You have the IPv protocol that I mentioned. We also have the IPv community soon. There you have linked to the IPv community where we discussed the ecosystem around that IPv protocol. And we have the SIG, Special Interest Group for Events in CDF. And in that, as I mentioned in the talk, we will soon have a birds of a feather session there with a small panel, including me and Andrea Frittoli and also Erik Sternerson. 3 of us, we are all in that SIG. So we are happy to talk to you there. I guess you can find the link to the BOF session yourselves. So now I got a question, I see. Do you have a more concrete example of a workflow leveraging these events? Oh, well, as I mentioned, we send multiple events, so actually millions of events per day in our CI/CD pipelines in Ericsson, and we use the events for telling that now we have made a source change, and now we have created a baseline or composition, as we call it, out of those number of source changes, and then those composition events link to each individual source change event. And on a composition, we then build some kind of artifact or multiple artifacts, and they then link to that composition. And then we test those artifacts. We have a lot of different test events. And we have something that we call a confidence level or maturity level, if you will, that when a certain number of tests have passed, we can set a confidence level on the artifact or the composition itself, stating that now we have reached a certain maturity level in our system, in our source code and in our deliveries. So I guess, and all these then are using links. So between all these events, there are multiple links going on. So we frequently do these so-called upstream and downstream searches on our events to trace what was included in a certain build, in a certain artifact, or what tests have been performed on a certain source change, and those kind of things. And we also calculate KPIs and keep track of our CI/CD system performance in that way. So I'm not sure if it's concrete enough, but I can just say we use them a lot. So for us, it's important. Let's see, have you used events together with something like open policy agents to act on events? No, not yet. I'm also part of the SIG interoperability. That's where the events SIG actually emerged from. And in there, we have recently started to discuss the Open Policy Agent and the policy protocol in large. So we haven't started to use it internally in Ericsson yet, but for sure it's something that we discuss, at least in the CDF SIGs. So please join there if you're interested to see how events and OPA can fit together. I certainly hope or think that there is a common ground for it. So I'm looking forward to investigate more on the OPA. Sure. Thanks for that thumbs up. Any more questions? Do you store events in a time series DB, or do you process them later for initial central storage? We currently store our events in a MongoDB, Mongo database, as documents then. So they are stored as plain documents, and then we have implemented in that MongoDB instance, we have implemented these upstream, downstream searches as entry points to the database. So we can easily get the full trace of the event, so to say. So, well, we store them, of course, with their timestamps intact, so they are just JSON documents. And then we also aggregate them in other systems. We have aggregations of these events, so we don't need to call this upstream downstream every time, but instead we actually consume events in an aggregation system as well, where we can build up aggregated objects, which are more tailored towards the needs that we would have as a consumer of those series of events or whatever. So we actually do such aggregations and store them as well as documents, actually. That's aggregated object documents, if that answers the question. Good. I think we have 3 more minutes, if I'm not mistaken, before the BOF session kicks off, and I will run over there to the other session. Hope to see you there as well. So do we have a final question before we all get ready for the BOF session? Doesn't seem like it. So thank you very much for listening to this talk, and I hope I can see you soon in any of the SIGs, either SIG events or SIG interoperability, or maybe in the IFL community. Why not? So you have all the links you need in the chat here. Yeah, as Emily puts it there, the BOF session, different BOF session going on, and I would of course recommend the SIG events BOF session, but you're free to go to anyone if you like, of course. I will be in the SIG events session together with Andrea and Eric. So I guess I'll see you there then. I will run over there right now. Take care. Bye.